Hey guys, so this video is for classifying between ionic covalent and also naming both ionic and covalent. So we'll just jump right in to talking about what an ionic bond is and what a covalent bond is. So ionic is metal, non-metal. That's an M. Non-M. And covalent is two nonmetals bonded to each other. If I could write. So when we look at the periodic table, over here on the right side, right below boron, you can see that there's this darkened line that kind of zigzags down. I apologize. Kind of zigzags down right here. That is the line that separates the nonmetals over here on the right to the metals down here. Or you can just look at these labels down here that tell you exactly what everything is. So, alkaline metals, alkaline earth metals, transition metals, basic metals, semi-metal and non-metals, halogens, noble gases, lanthanides, acinides. We hardly ever deal with lacinides and acinides. Sorry. Okay, so let's hop right into the first one. So let's determine if this is, first off, ionic or covalent. So since I see Fe right here, when we go over to the periodic table, iron's right here in the middle, it's 26. So that is a metal. So immediately I can say it's not covalent because covalent is two nonmetals. So it's ionic. And then we must name it. So looking at our common polyatomic ions that you guys have to remember, but I have a list of, in order to memorize them, go talk to your professor. They'll tell you what you need to memorize. And then you also have to memorize the diatomic, which is in the email that I sent you. So, oops, it's SO4, so let's see if we can find SO4 on this thing. So SO4, right there on the bottom, has a 2- charge on it. So then FeSO4. So 4 has a 2-, and there's 3 SO4s, so write the 2- 3 times. Iron, there's 2 of them, and it has to counteract all this charge with only 2 irons. So that's a sum of -6. And then, so all of the nonmetals, which is this polyatomic ion, right? It makes up a -6 charge for this iron to counteract. And there's 2 irons, so each iron is going to be +3 and +3. A method of doing this is to, first off, sum up all of the nonmetal charges. So -2, -2, -2, because there's 3 of those and there's 2 irons. And then when you add that all up, it's -6. And then you divide it by this number right here. And then the absolute value of that, which basically just makes a negative a positive, is the charge of iron. Because the charges from the irons have to cancel out the charges from what it's bonded to. So iron has a +3 charge. So therefore, the naming would be iron 3. Oop. Roman numeral 3. 3. And that's sulfate, I believe. Yep, sulfate. On to the next one. N and F. They're both nonmetals. Because when we go to the periodic table, N is right here. Its atomic number is 7. F is in the halogens. So both nonmetals. Therefore, it's a covalent bond because it's nonmetal bonded to nonmetal. So looking at NF, we know it's covalent. And then we have to name it. So it'd be nitrogen trifluoride. I can't spell fluorine. Fluorine. I don't know how to spell. Sorry. So looking at the next one, we get silver chloride, I believe. No, chlorate, maybe. AgClO3. Yep, chlorate. So we get silver chlorate. Chlorate has a -1 charge on it. So when we go back to Word, we have, well, it's ionic because silver is a metal. And then chlorate has a -1 charge. And there's only one chlorate in this molecule. So we know that the silver has a +1 charge. So that'd be silver chlorate. The times where you don't need the Roman numerals in an ionic bond is when the charge is just 1, because it can be assumed that its charge will be 1. Let's move on to the next one. We got silicone and bromine. So we go over to the periodic table. Bromine is over here in the halogens. Si is a little bit harder to find. Where is it? I think it's... Okay, I'm completely blind. Hold on. Okay, I found it after pausing. It's right here, 14, silicone and bromine. So they're both nonmetals. So it's covalent. And so that would be disilicone bromide. Oh, nope. Hexabromide. Because you got to use the prefixes in order to indicate how many there are, because you can't use charges like you can in ionic to determine that. So zinc is a metal, ZnCO3. So that's zinc carbonate, I believe. CO3. Yep, carbonate. Carbonate has a -2 charge. Therefore, zinc has a +2 to cancel that out, right? Okay, so then we're going to have zinc 2 carbonate. It's ionic. Yep, the next one, copper is also a metal, so it's also going to be ionic. S has a -2 charge. Copper would then have a +2 charge. Copper 2 sulfite, I think. Just an S would be sulfide. It does that sometimes. It's really annoying. Sorry about it. Sulfide. Copper 2 sulfide. If you don't understand where I'm getting these values for the metals, because the transition metals have variable charges, I'm using the non-metal. So the charge on the metal has to cancel out the negative charge on the non-metal to make the entire molecule neutrally charged, which means have no charge. So the CO3 in part E had a -2 charge, so zinc had to be +2 to cancel that out, because there's only one zinc per one CO3. Does that make sense? I hope so, because I can't answer. I can't answer if you're asking your screen. So B2, Si, they're both nonmetals, so that'd be covalent. And then that'd be diboron. Silicide, I think. One sec, let me check that. It is silicide, so it's diboron silicide. Yep. All right, see you guys. Move on to the next chapter.